Hello, this is Mahendra Ditya. This submodule is incorporated in the book on liquid formulation and focuses on suspension clinical study formulations. The clinical study generally starts with bioavailability of the suspension. There are two different bioavailabilities. Absolute bioavailability is measured by comparing the AUC of administered dose to intravenous dose. Relative bioavailability is the AUC of the administered dose is compared to a reference product. For example, suspension dose is compared to a tablet or a capsule dose. The bioavailability is shown here. Area under the curve for the graph here is drug given orally and intravenously. Intravenous is defined as 100% bioavailable. So the ratio of AUC of oral to AUC of intravenous provides the absolute bioavailability. Suspension formulation of coenzyme 10 nanocrystal is evaluated to see the effect of active particle size compared to bulk and the commercial product of coenzyme 10. The preparation of this product is by anti-solvent method. Anti-solvent method, the drug is dissolved in a solvent and then anti-solvent is added to produce crystal which then are suspended into the vehicle. In this case, drug is dissolved in 3 milliliter of alcohol. So the variables in these studies are the drug particle size, amount of drug in the solvent ethanol changes from 10 to 30, temperature of ethanol changes from 60 to 50, and the RPM anti-solvent, in this case water, ethanol system, and the mixed up. So this method depends on the growth of the crystal. Ethanol injected in water, very short duration, at extremely high speed will produce smaller crystal. Crystal will not have chance to grow and that will produce small crystalline material. As compared to same drug at higher concentration, at lower temperature, slower rate, and slower mixing time to grow crystals. So this type of techniques are used in research mode. This is compared to the bulk drug dispersed in 30 ml of water and ethanol. So drug we studied to see the effect of particle size and the bioavailability. In this nanosuspensions are obtained. Particle size remain constant over 30 days at room temperature, indicating good stability. Transmission electron microscopy TEM shows discrete particles and zeta potential varies from -5 to -30 and bulk coarse suspension separates with a cake at the bottom. We can look at TEM and TEM of 80, 120, 400, and 700 nanometer particles show each of these particles are separate. We look at pictures, bulk, we can see the settling of at the bottom. 80 nanometer is translucent, and as the particles increase, they become more and more opaque. 700 nanometer is very opaque with zeta potential of 5 millivolts. So the solutions of coenzyme 10 suspension at 0.6 milligram were determined. Method used is a USP pedal method. It is at 25 degrees C and 100 RPM. 3 dissolution medias are used. Water with 1.3% twin-20, water with twin and isopropanol of 5%, water twin-20, and 10% isopropanol. Bulk coarse material also included in the dissolution study. So different medias and different particle size show clearly different dissolution profiles. In media A, which does not have isopropanol, dissolution rates at 2 hours are slow for 80 and 120 nanometer, and there is not significant dissolution in 400, 700 nanometer particle size and coarse material. Media B, which contains isopropanol, increase in the solution for 80 nanometers. The rest of the materials behave the same as before. When isopropanol is increased to 10%, 100% of the drug is dissolved at 80 nanometer, 90% at 120. Small amount of drug from 400 nanometer, 700 nanometers are also dissolved. And media C at 25 hours, 80 and 120 nanometers show 100% dissolution. 400 nanometers significantly shows better dissolution. However, 700 incomplete dissolution. This is graphed, and graphs also show media A, B, and C, and different particle size. 80 nanometer is a higher, and 120 followed by that. Obviously, 400 and 700 do shows the solution in media C that contains higher isopropanol. The relative bioavailability of Q10 nanocrystal core suspension compared with commercial capsule. This is a preclinical study in beagle dogs, which is common in an early stage development. Crossover study is designed, which each dog received each of the 6 doses. Dogs are fasted for 12 hours before dosing orally, and samples are collected from dog for drug analysis in their blood samples. The mean concentration of 12 dogs at different time interval and the dissolution here is shown. And as can be seen, 80 nanometer shows the highest bioavailability compared to commercial capsule. So that's a commercial product. We state that as 100%. Compare all other bioavailability to that. And bioavailability increases for 120 to 700 nanometer particle size. One can conclude from such studies that particle size, the nanocrystals, dissolution rate is a significant factor affecting bioavailability, and particle size is affecting dissolution rate. Particle size from 700 to 120 nanometers show increase in AUC, area under the curve, and shows marked increase with 80 nanometer. So this kind of preclinical data is then used by formulation scientists to develop a stable formulation. And in this case, it would be a nano formulation, particle size less than 100 nanometers. We'll look at another study. In this case, Tiglutic, which we had looked at a previous video about its manufacturing, including quality by design in previous submodule. In this case, we are looking at bioequivalence study. In this case, plasma profile of a test drug suspension is compared to the reference drug, in this case, film-coated tablet. Since film-coated tablet is approved, we can do bioequivalence study in human to get approval of the suspension. Dose administered is exactly the same, 50 milligram in both. The route is exactly the same, oral. In this case, A, B, and C are as designated. A is fasted state. C is a conventional fed state. We want to make sure the suspension behaves similar as compared to the reference product in both when administered with or without food. The results are shown here as a graph. Tablet is shown as a blue line, and it can be seen here. The suspension is a red line and is shown here. In addition to that, suspension is given in a fed state. When the drug is given in the fed state, there's a decrease in absorption. This is similar to the tablet formulation. Based on this type of information, FDA will approve the drug for commercialization. These type of studies are commonly done for suspension product where they are compared to existing commercial tablet product or a capsule product.